Alright, so this is CHIJ E-Maths paper 1, question 21. So this is testing on our prime factorization, right? And this type of question is also very common in O-level. You will definitely see in O-level. Okay, so question 21a, write 756 as the product of a prime number. So remember, prime number starts from 2. Okay, 2, 3, 5, 7, so on and so forth. Okay, so prime number can only divide by itself. So if I want to express my 756 as a prime number, right? So I just divide my 756 by prime numbers, right? So I'll divide until I'll get 1. So 756 divided by 2, you should get 378. Okay, so 378 divided by 2, you get 189. So 189 continue divide by 3, you should get 63. 63 divided by 3, 21. So 21 divided by 3, 7, right? 7 again divided by 7, you should get 1. So now I have divide all my 756 totally already. So 756 is equal to 2 to the power of 2 multiplied by 3 to the power of 3 multiplied by 7 to the power of 1. Okay, so this is how I prime factorize a number. Okay, so part B is the question that I want to emphasize is that k is the smallest possible integer such that when I square root 756k, I will get some integer. Integer means it's a whole number. So I want to find n. Normally they will tell us to find k, but this one is a bit special. They tell us to find n. So I have two things to find. One is I need to find what is my k. Second is after finding my k, I need to find what is my n. Right? Okay, so what do I mean by square root 756k? Okay, in order to square root any number, let's just say thing. Okay, so let's just say I put 4. Okay, 4 is what we call a perfect square, because when I square root 4, I can get a whole number, which is 2. 4 is a perfect square. Sorry, not 9. 3, yeah, 9. 9 is also a perfect square, because when I square root 9, I'll get 3. So 25 is also a perfect square. Yeah. So what do I mean by perfect square? If you look, I prime factorize all these number to 4, 9, 25, right? I prime factorize it. So 4 is equal to 2 square. And of course 9 is equal to 3 square. 25 is equal to 5 square. Okay, so there's one very prominent thing that we can see is that you look at the power. Okay, you look at the power is 2 right here, 2 right here, and 2 right here, right? In order to square root it, your power must be a multiple of 2. Okay, so let's just say I give another example. 64 is also a perfect square. So if I prime factorize my 64, I should get around okay, so 2 to the power of, okay, so 2 to the power of 6. Okay, when I square root my 64, I should get 8, right? Okay, why can I square root 64? Because the power is a multiple of 2. So multiple of 2 is 2, 4, 6, 8, 10, right? So it's consistent. Okay, so if I look at my 756, my prime, in terms of the prime factorization, my 2 to the power of 2, so 2 to the power of 2 is okay, because 2, the power is a multiple of 2. But if you look at the green color, 3 to the power of 3, the power is 3. So it's not a multiple of 2. So I need to make the 3 to the power of 3 in terms of multiple of 2. The 3 must be a multiple of 2. So my k, in order to make it, I need to make sure that my k is equal to 3. Because 3 to the power of 3 times 3 to the power of 1 is 3 to the power of 4. Okay, next is your 7 to the power of 1, right? So the 1 is not a multiple of 2. Okay, so I need to multiply that by another 7 to the power of 1. Okay, so in this case, I have made my 756k in terms of all the power is a multiple of 2, right? So let me just write down. Okay, so if I write 756k, right, So 756k means 756 times k. So times k. Okay, so 756 is 2 to the power of 2 multiplied by, okay, just put here, 3 to the power of 3. Okay, multiplied by 7 to the power of 1. So this is 756 in terms of prime numbers. Okay, what about my k? My k is 3 to the power of 1 multiplied by 7 to the power of 1 bracket. Okay, if you combine all this together, you should get 2 to the power of 2 multiplied by 3 to the power of 4 multiplied by 7 to the power of 2. Okay, so now all the powers are multiple of 2, which means I can square root it. Alright, so now I find my k already. Okay, I can square root this, right? If I square root my 750, this number, new number, 2 to the power of 2 times 3 to the power of 4 times 7 to the power of 2, what can I get? Very simple. Alright, so you just square root each of the number you see. Okay, so you square root this, right? 2 to the power of 2 multiplied by 3 to the power of 4 multiplied by 7 to the power of 2. Okay, so you see 3 numbers, right? You just square root. So 2 to the power of 2, you square root, you should get 2 to the power of 1 multiplied by 3 to the power of 4, you square root, you should get 3 to the power of 2 times, last but not least, 7 to the power of 2, you square root, you should get 7 to the power of 1. So the integer is 2 times 9 times 7, which is 126. Right, so the answer is 126. Okay, yeah, so this is a very common type of question, but normally they will ask us to find k instead of n. Right, okay, so part C, on one visit to her local swimming pool, the Ellie swims 40 length. So the first length she swims is length 1, second is length 2, and so on so forth. So she swims on her back on lengths which have numbers that are multiples of 4 or 5. Calculate the total number of lengths that she swim on her back. This one is simple, because you just need to list out all the multiple of 4 and all the multiple of 5. So 4, so 4, 8, 12, 16, 20, 24, 24, 28, I list until 40, right? So 28, 32, 36, 40. Okay, so next will be 5. So 5, 10, 15, 20, 25, 30, 35, 40. Okay, so I list all the multiples already. But for this question, be careful, because if you are not careful, you might do what we call the double counting. So you count the same thing twice. Okay, let's count. Okay, so I will swim on my back. I mean, she will swim on her back when they have numbers of multiples of 4 or 5. Okay, so so 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. So all these will be the time where she swim on her back. Okay, so if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that 10 lengths already, right? Okay, next I will count my 5 already. So 5, okay, 10, 15. So if you so the fourth is the 20, right? So we should not count this, because I already counted the 20 already. Okay, so 25, 30 I count, 35 I also count, because it does not appear on my multiple of 4. Okay, the last one is 40. I cannot count, because 40 I already counted already. So so if you count, is what we call double counting. Okay, so let's count. So 10, right? 11, 12, 13, 14, 15, 16. So there are about 16 lengths that she will swim on her back. Okay, so part C is rather tricky, so you need to be careful.